Hello, in this episode we're going to be adding the ability to toggle a path as either closed or open, and we'll also be adding an option to automatically set the control points based on the positions of the anchor points. This is of course particularly useful for applications in procedural generation, where there's obviously no human around to set them by hand. Okay, so here is an open path, and here is a closed path. Now, all that's changed is that we've added this control point opposite that one, and this control point opposite that one. So to close the loop, we just add two new control points. So I'm going to head over into the path class, and here I'm going to create a bool called isClosed. And just like the points list, I want that to be serialized but hidden in the inspector. And then I'm going to make a method. I guess I'll just put that at the bottom here. It'll be a public void toggle closed. All right, so this will set isClosed equal to not isClosed. And then we'll say if the path is now closed, then we're going to want to add those two control points. So let's quickly go to the add segment method. And this first line of code here is doing exactly what we want for the first control point. It's just adding one opposite to the last control point. So let me paste that in there. And then I'll paste that in a second time. So for this one, we just want it to be opposite the first control point. So I'll just change this to points 0 for the first anchor point, and this to points 1 for the first control point. Okay, then if it was closed but is now open, then we're going to want to just remove these two extra control points we created. So I'll say points.removeRange, starting at points.count -2, and just removing those last two. Okay, now we'll need to update the number of segments to reflect the fact that when the path is closed, there is one extra segment. Now, originally I was just going to add one here using a ternary operator, but happily a viewer pointed out a much cleaner approach in the comments to the last episode, which is as follows. If we have one segment, then we'll have 4 points, 2 segments will have 7 points, 3 segments 10 points, and so on. So if we divide each of those by 3, always rounding down, we get the correct number of segments, 1, 2, and 3. So that is for an open path. Now for a closed path, there are always just 2 extra points, so it would go 6, 9, 12, and so on. And if we divide each of those by 3, we get 2 segments, 3 segments, 4 segments, which is correct. So we can replace this convoluted nonsense here with points.count divided by 3. Okay, now we have a small problem in the getPointsInSegment method, which is that if we're on the last segment of a closed path, then this very last point here should refer to the first point in the list, since it's now wrapped all the way around, but instead it's currently just out of range. Related to that problem in the movePoint method, here and here we are only moving certain points when they are inside of the list, but when the path is closed, we just want to wrap around to the other end of the list. So I'm going to create a private method returning an int called loopIndex. So we'll take in an int I, and this is going to return I plus points.count mod points.count. So that will just wrap the index around, and the reason for adding points.count here is just so that it handles negative values properly. So if we're given a value of -1, for example, that should wrap around to points.count -1. Okay, so let's use that method to solve all the world's problems. In the getPointsInSegment method, I'll just wrap this in a call to loopIndex. And then in the movePoint method, in each of these cases here, we can say we only want to move the point if it's in range, or if this is a closed loop, then everything is in range. We just need to make sure that we loop it with a call to loopIndex. All right, so I'll do that here as well. Or is closed and loopIndex. Okay, one more place for that over here. or is closed. And then we're going to have to loop all instances of the anchor index as well as the corresponding control index here. So let me write loop index, anchor index, and I'll just copy and paste that over here and over here, and then loop index, corresponding control index, and I'll copy that, and I think there's only one other place, which is there. Okay, so that should now be working. Let's save that, go into the path editor, and add a button for toggling the path open or closed. So I am going to override the onInspector GUI method, and here I'll say if GUI layout.button, and I'll give that some text, I guess just toggle closed. So if that button is pressed, then we're going to call path.toggle closed. We'll probably also want to force the scene to repaint after that, so we can just call sceneview.repaintAll. Now, while we're here, might as well add a button just for manually creating a new path. So I'm just going to copy paste this. I'll replace the button text with create new, and this will have a call instead to creator.createPath, and we'll want to update our path reference then, of course. So then path is equal to creator.path. All right, let's save that and have a look. So here I'll try creating a new path, and we've got a nice new path there. Create new, it's working. And now if I toggle closed, that is now closed, and we can still move the points around the join there, nothing's going wrong. And if we toggle again, now it's open. Okay, so the next thing I want to do is add an option for automatically calculating the positions of the control points. Now, there are any number of ways of going about this, but the idea I'm going to use is as follows. At each anchor point, look at the angle it makes with its neighboring anchor points. Then bisect that angle and place the control points along the line perpendicular to that. The distance of each control point from the anchor point will be half the distance from the anchor point to the neighboring anchor point. Now, the way I'm actually going to calculate this is a bit different to what I've just described, but amounts to the same thing. We first find these offsets to the neighboring anchor points, then normalize them so that they're the same length, and then simply subtract the one from the other, which will give us the direction we want. Okay, so in the path script, I'm going to create a method called something like AutoSetAnchorControlPoints, and this will take an integer for the anchor index. So I'm just going to start by getting the position of that anchor, so call this anchorPos is equal to points with that anchor index. Then I want a vector2 direction, and this will just be vector2.0 at the start. Then I'll also have a float array called the neighbor distances, just for the distances from the anchor point to its two neighbors. So I'll set that to a new float array with a size of 2. And just add the new keyword there. Alright, so for the first neighbor, let's say if anchor index -3 is greater than or equal to 0, or if this is a closed path, then we can get the offset from the neighbor to the current anchor by saying vector2 offset is equal to points, and I'll use this loop index method, passing in anchor index -3, and then from that I'll subtract the anchor position. Then I'll say direction plus equals offset.normalized, and the neighbor distances with an index of 0 is equal to offset.magnitude. Okay, I'm now going to copy this and just paste it for the second neighbor. So this will have an index of anchor index +3. So let me just replace that in both cases. And here I want to subtract this from the direction. And I'll say neighbor distances 1 is equal to negative offset.magnitude, just so that it goes in the other direction. Alright, I'll now just have a little for loop to set both of the control points. So I'm going to go for int I equals 0, I less than 2, I plus plus. I'll say int control index is equal to the anchor index plus I times 2 minus 1. So when I is 0, that will be anchor index minus 1, and when I is 1, it will be anchor index plus 1. Okay, we want to make sure that that is in range. So if control index is greater than or equal to 0, and control index is less than points.count, or of course, if it's a closed path, then we can say points with an index of loop index control index, and I'm going to set this equal to the anchor position plus the direction multiplied by neighbor distances with an index of I multiplied by a half. Now I should actually normalize this direction before I use it. So just before the loop, I'll say direction dot normalize. Okay, now for an open path, the positions of the start and end control points are going to be a little bit different. Basically, I want to position them halfway between their anchor point and the next control point. So I'm going to make a separate method, void autoset, I'll call this the start and end controls. Let me just first make sure that this is a open path, and then I'll say points with an index of 1, so that's the first control point, is equal to, in brackets, points 0, so the first anchor point, plus points 2, the next control point, multiplied by a half, so halfway between them. And then I'll do the last control point, so that's points.count minus 2 is equal to points with an index of points.count minus 1, the last anchor point, plus points with an index of points.count minus 3. And once again, multiplied by a half. Okay, I'll then have a method autoset all control points. So this will start by looping through all of the anchor points. So for int I equals 0, I less than points.count, and we know every third point is an anchor point, so I plus equals 3. Say auto set anchor control points, passing in I as the anchor index, and then after having done that, I will auto set the start and end controls. Now, when we do something like move an anchor point, it's a bit overkill to set all of the control points again. We only need to set the control points for the surrounding anchor points. So I'm going to have a method auto set all affected control points. This will take in an int for the updated anchor index, so the index of the anchor that's been changed in some way. So in here I want to call auto set anchor control points on the updated anchor index as well as its two neighboring anchors. So I'm going to have a loop for int I equals updated anchor index minus 3, I less than or equal to updated anchor index plus 3, I plus equals 3. I want to make sure that this index is in range, so I'll say if I is greater than or equal to 0, and I is less than points.count, or it is a closed loop, then auto set anchor control points, passing in loop index I. At the end of this, I'm just going to call auto set start and end controls, just in case they're affected. Okay, let me now come up to the top here, and I'm going to create a bool auto set control points. And I want that to be serialized and hidden in the inspector, so I'll copy that. And I'm going to create an accessor for it. So somewhere here I'll have public bool, and I'll call this auto set control points as well, just with a capital A. And in the get block, I'll simply return the value of the variable. So return that. And in the set block, I'm going to say if the current value is not equal to the new value, then I will assign it. And if it is now true, so if we're auto-setting control points, then I want to update all of the control points, so auto-set all control points. I'll now come down to the movePoint method, and here I'll say if we're auto-setting control points, then I want to auto-set the affected control points, and the updated anchor index is I. And only if we're not auto-setting control points will we actually worry about doing all of this manual stuff. I'll then come to this toggle closed method. So if it's been toggled closed, then we only need to update the control points of the first and last anchor points. So if auto-set control points is true, then I'll say auto-set anchor control points with an anchor index of 0, and auto-set anchor control points with an index of points.count -3. If, however, the path has just been toggled open, then I'll say if auto-set control points, then I want to auto-set the start and end controls. Alright, the last case is when we're adding a point. So let me see. This is the add segment method. After adding the points, I'll say if auto-set control points, then I want to auto-set the affected control points, and the new anchor point is the last element in the points list, so points.count -1. Okay, I'll save that and go into the path editor, and here in the inspector GUI method, I want to create a toggle for that auto-set control points bool. So I'm going to say bool auto-set control points is equal to editor GUI, actually I want GUI layout dot toggle, and I'll pass in the current value, so path dot auto-set control points, and then a label, so just auto-set control points. And I'm going to say if the value has changed, so if this auto-set control points is not equal to the current value there, I'm going to first record this with the undo system. So I'll record the creator object, and for the undo name, I'll just call this toggle auto-set controls. And then path dot auto-set control points is equal to auto-set control points. While I'm here, I'm just going to add this undo functionality to both the toggle closed and create new buttons. So I'll paste that in there. This will be toggle closed, and here create new. Now I also want to repaint the scene when this changes, but instead of making all of these separate calls, I'm just going to begin a change check up here, and then at the end, if editor GUI.end change check, so if something's changed, then I'll repaint the scene. Okay, so let me go into Unity, and with auto-set control points turned off, can, as before, just move these anchor points around, and the control points just stay in their manually defined positions. But as soon as I turn this on, you can see it all jumps into place, and now as I move the anchor points around, they're all changing based on that algorithm we wrote to try and make a nice looking path. Now, of course, it's not always going to get it exactly how you want it, and in some configurations might end up with weird twisting that you don't want, but for the most part, I think it gives fairly nice results, and there's no doubt room for improvement with the algorithm if you want to tinker around with that. Now, the last thing I want to do this episode is just forbid the movement of these control points when auto-set control points is turned on. You can see if I try and move this, then weird things happen. So I'm going to go back to the path script, to this movePoint method, And I'm going to say that the position of the point can only be set if either it is a anchor point, so I mod 3 is equal to 0, or auto set control points is not turned on. So I'll enclose all of this in that if statement, and then we are done for this episode. So until next time, cheers.